Today we're going to be focusing on solving inequalities. Firstly, we're going to look at the difference between an inequality and an equality to try to see what exactly do these two things mean, and then we'll look at a later stage quadratic inequalities to try and see then how does an inequality change from being just a linear thing to being a quadratic thing. But for now, let's just look at the question that is going to lead this particular lesson at the moment. So, have you ever thought about how does an equality differ from an inequality, right? So you know that equality would mean something that is equal another thing, and inequality, does it mean the same thing or is there something different there? But we're just going to talk about that as we move along. Our map for this lesson, we're looking at algebraic inequalities. There's going to be symbols that are going to represent inequalities, and there are types of inequalities, which is the quadratic and the linear, but we're going to start with the linear first. There's some rules that we need to adhere to when we're solving inequalities, and also there is 3 methods that we normally employ, and you guys can then always choose whichever one works for you best. The keywords for this lesson is an inequality. We're going to look at what exactly is an inequality, and then we will then make it to be a linear inequality and try to see how do we then talk about a linear inequality. Now, an inequality, compares two values, right? What does this mean? It means one value might be bigger than the other value, or it might be smaller than the other value, or it might not be equal at all. So this shows that whether one value is equal to another or not equal to another. It shows whether one value is less than another value. Lastly, it shows whether one value is greater than another value. And we're going to use symbols because we're not really going to write words like this when you're talking about inequalities. So in terms of symbols, not equal, you know that is an equal sign with a transversal in between, so like a slash, says that A is not equal to B. And you know, if I just said A is equal to B, whatever that A is, B is that as well. But if you put a slash in between there, it means it is not equal to. Then the A less than, so this symbol that I have in between these two letters actually says that A is less than B. And the one that I have now here that is facing the other direction says that A is greater than B. These two symbols are known as our strict inequalities. Why am I saying they are strict inequalities? Because at times it might be that A is greater than B, but also A is also equal to B. So we look at how do we then write that as a symbol, right? That's what I'm saying. These are only the strict inequalities. As soon as we introduce when A now is also equal to whilst it is greater than or less than B, then we're talking about an equality. That's where the difference between equality and an inequality comes in here. I'm not really talking about equality and inequality under general language terms, right? It's mathematically based, whatever that we're going to talk about here. Now, in terms of examples, you need to always remember which way around this goes. So the bigger value, wherever the inequality is opening to, will be the bigger value, and wherever the sharp point is facing will be the smaller value. So that's just one of the ways that I can try and help you remember how to look at this. And wherever, remember I said the sharp point is facing is the smaller value, and wherever it is opening to is the bigger value. Some people, they use their hands, right, to show you that which one is greater and which one is less. The right hand side, if you bend your elbow like this, will be greater than, and your left hand side, if you bend it like this, will be less than. So whatever that is this side will be less than me, but whatever that is that side of my elbow will be less than me, meaning I'm greater than that particular thing. So those are just things that we will be looking at as a frame of reference for this particular. So that's just one of the ways you can remember which direction the sign goes in. Now, in terms of typical examples, I have -5 is less than 3. Remember, wherever the sharp point is, means it is the small number. Wherever the inequality is opening to is the big number. So if I wanted to show you this in terms of a number line, I would then say that this is an unknown, right? I would treat maybe my 5 as an unknown, meaning from the value 3, I am looking at all the values that are that side, right? So you know that -5 will be somewhere at the side on a number line, meaning it is less than the 3. And then when I look at 3 greater than -5, it's just the other way around, but it really means one and the same thing. Now, equality and inequality now, if I have A is less or equal to, the symbol actually says less or equal to, and I'm quickly going to make an example for you to understand this, and this symbol will mean that A is greater or equal to B. In terms of an example, if I have a plastic bottle, right, and I am told that it can hold up to 440 milliliters of cold drink, you know, the one that we buy from the tuck shop, how much cold drink is in the bottle? So it can hold up to, meaning the maximum capacity of the bottle is 440 mils. But it can also hold less than that. So the first point will say it can hold, or rather it could be 440 mils of cold drink, or it could be less than that. Why? Because the up to part means that's the maximum, but it can hold less than that. Now, we say this mathematically, we say that it is less than or equal to. So what I will then say, I will use B for the bottle, and I will say it is less than or equals to 440 mil. So the bottle can hold either the 440 or anything less than the 440. So that's just a typical example of how you can then think about this. You can even think about a mug. If I say a mug can hold 10 grams of sugar, maybe, how much is a maximum? And I ask you, how much sugar can be in the cup? You can then say either 10 grams or anything less than the 10 grams. So you'll say mug less or equal to. So that's how you just have a look at the inequality and equality. But for now, I want us to take a quick ad break. When I come back, I'm then going to make this more abstract and more mathematical in terms of a linear equation where we have an unknown and try to talk about how do we then look at that based on a number line. Please stay tuned. I'll be back just now. Hi guys, welcome back from the ad break. So as I said, that when we come back, we're going to look at a bit of more linear inequalities and try to see now how do we represent these things. What does exactly a linear inequality mean? On a number line, graphically, how do we look at those? Remember I said we will use 3 methods, right? A number line, a table, and a graph. So we're going to look at those different options and try to see exactly what does it mean. But for now, let's just jump right into it. So, all right, so firstly we look at what is the definition of a linear inequality, right? This will be a mathematical statement that relates a linear expression as either less than or greater than another expression, right? A linear expression that is. Also, this linear inequality, we can use a number line to represent it because it really just talks about less than or greater than. But remember, I said equality can be thrown in there as well. You can say less than or equal to, or you can say greater than or equal to. So you can always throw in that, but we'll look at it at a later stage. Now, if I have an unknown is greater than 5, which is the same as x greater than 5. If I want to represent this on a number line, I will then say that if I have 5 there, anything that is greater than this, meaning bigger than 5, will satisfy this solution that I have here. So firstly, I will have an open circle. Open circle really means that 5 is not part of the solution, right? And then I want everything that is greater than 5 without having a limit to what number must I end at. Hence, my arrow just points to the right-hand side of 5. So everything that I have here on the number line will be 6, 7, 8, 100, 150, 2,000, and all of that. All of those numbers are said to be greater than this 5, but excluding the 5 itself. Now, if you say x is less than now -3, same thing. On the number line, I will say that's my 0 there, -1, -2, -3. I continue with my number line. From -3, I want everything that is less than this, right? But you know, with negatives, the bigger negative numbers are actually the lesser numbers, especially on the number line. So it means it will be on the left-hand side of the -3. And this is how you will leave it. As soon as you introduce equality, then you must shade this circle, but we'll talk about that just now as well. Now, for which values of x, so what are the values of x? All of them, right? Without having a limit, as I said. Will this situation here become true? So this expression of -2x is less than -6 become true. Now, I want us to first test some values here because we don't really just want to then thumbsuck it and say, this is the answer. Firstly, we need to look at it graphically in terms of a table. If I take x as -1, right, and I substitute it there, it will be -2 into -1, which is a +2. A +2 less than -6 is a lie. So this is false. It is not true. 2 is definitely greater than -6. If I choose 1 as my x, it will give me the left-hand side as a -2, and then it says -2 is less than -6. You can see as well that this is also false. If now I take 3, it says -6 is less than -6, but this is false. But the interesting that you need to see here is now we are like at the midpoint of our solution, right? So it's either you are on the left-hand side of the -6 or you are on the right-hand side of this -6. But the value that gave us the -6 was 3. So it means everything that we used that was less than the 3 did not give us a true solution. So even 3 itself does not give us a true solution. We will then look at everything that is greater than the 3. Will it make this thing to be true or not? And that's how we then determine our solution. So let's have a look at it. Now, if I take a number greater than 3, I chose 6. If I substitute 6 there, I will get -2 multiplied by 6, which gives me -12. And -12 is definitely less than -6, so this will be a true statement. So it means that all the values that are greater than this 3, because I said this 3 is like our midpoint, will then satisfy that particular situation that we have there. Now, to solve these algebraically now, you then need to change the direction of the inequality whenever you multiply or divide, right? So, or divide by a negative number. So my question, remember, was -2x less than -6. I must divide both sides by -2 because I want x to be on its own. But one of the rules that we need to adhere to is this must change direction, the inequality sign, because of the negativeness of this, which will then make this x greater than 3. If I go back to my table, remember, 6 is definitely greater than that 3. And I said it is part of what makes this statement to be true. So the last important point there will be the inequality sign is reversed. So it changes the direction it was facing initially. But if I divide just by a positive number, then you don't change the direction. So you do not change the direction of the inequality when you multiply or divide by a positive number. So dividing both sides by 2, it will be -6 divided by 2, which will give me -3. Then my x is less than -3. It still remains. So the inequality is not reversed. As I said, you don't change the direction here. And this is when you then solve it algebraically. Now, represent the solution on a number line. Remember, to do that, you look at where 3 is. This is where 3 is. The x value here is a range, right? Is a number of x values that satisfy the condition of being greater than the 3, because we're using 3 as like our starting point, but we are not including the 3. So it will be an open circle there, and it will go to the right-hand side, because that's where all the values are greater than that 3. If now it's an x is less than -3, on a number line again, it will be -3 there. From -3, I want everything that is less than the -3 itself, which will be on the left-hand side of that particular -3. Remember, open circle is when the number we are using as our starting point is not included. As soon as there's a bar there that shows equality, then we must include it by shading it. But now I want us to try and look at how do I then solve for x and represent this solution on a number line, right? To do that, you follow your basic algebraic rules. So this will be 2x minus x less than, and this will be 5 plus the 3, and 2x minus x will be x, and this will be less than 5 plus 3 will then be 8. So it means x is less than 8. So anything that is less than 8 on a number line will start from 8, but excluding the 8, hence it's an open circle, and it will go to the left-hand side because that's where everything is less than that 8. But I want you to then show this in terms of a graph. Now, remember, guys, I know that maybe you might have not looked at graphs as yet, but you've done graphs at the earlier grades when you were doing your maths. So here you will then draw the two graphs and look at where one is below the other or where one is above the other. So that's the condition that we are trying to look at graphically here. So it means if I say 2x minus 3 less than x plus 5, I am simply saying that the 2x minus 3 must be below the graph of x plus 5 if you draw this graphically. So to show you the two graphs, my blue graph here will be the 2x minus 3, and the other color here, which is like orange, will be x plus 5. Now this is simply saying I want where the blue graph is below the x plus 5 graph. Now we will look at where they are first intersecting, right? And we use that as our midpoint. On the left hand or on the right hand side of this, I mean, you can see the blue graph is above the orange graph. But on the left hand side here, the blue graph is below the orange graph. So to show you this in terms of how do you then see it on a graph? Where they are intersecting, that's 8, right, and 13, but I'm only interested in the x value because we're using the horizontal axis. It means from 8 going to the left-hand side, this statement will be true, the 2x minus 3 less than x plus 5. So if you write this as a solution, you will then say my x is less than positive 8. Remember, if I go back to what I initially had when I was solving, I said this was x is less than 8 when I was solving this algebraically. So I can even show you this on a graph. Hence, I drew the two graphs. Now, let's look at some more questions to try and solve. Remember, whenever there are brackets, you must definitely get rid of those brackets. So this will be 5x minus 5 greater than 7x minus 7, right? And then I want to simplify this. It becomes 5x minus 7x greater than negative 7 plus the 5, right? Remember, you add the additive inverse on both sides in order to get x to be on its own, which will then give me negative 2x is greater than negative 2. Divide both sides by negative 2. Remember, the direction of your inequality must change, so it becomes x is now less than 1. And that's all the values that will satisfy this condition that I have here. And then another type of question that I have here, it's still a linear, although it has fractions, and I know that fractions can then throw you off. But remember, you multiply everything by the LCD, which is 12. It will then give me 3 into 3x plus 2 minus 4 into x minus 6, and this will be greater than 0. Remember, 0 multiplied by anything is always 0. And this will be 9x plus 6 minus 4x plus 4 multiplied by 6 will be 24, greater than 0. The 6 and the 24 gives me 30. The 9 minus the 4 gives me 5x is greater than negative 30. Then my x will be greater than negative 6 if I divide both sides by 5. So on a number line, this will then be, my x is here, so it's negative 6, must be greater than this, so it's on the right-hand side of this. Please remember to always open your circle. Also, I remember I didn't draw 1 for this one, so my number line will look like this. X is less than 1, so 1 there, from 1 to the left-hand side of 1. And that's how you will then represent this as a solution. Inequality is not just one specific value. It's a range of values that satisfy the condition of x being greater than negative 6. All right, guys, that's it from me. I hope you are still having so much fun. But for now, I want us to take a quick ad break so that you can just refresh and try to reflect on everything that we've learned thus far. And when you come back, we'll look at some more work. So please stay tuned. I'll be back just now. Hi guys, welcome back from the ad break. We are still looking at inequalities, but now we are going to look at them from a quadratic perspective. Remember, I said there's two types according to our mind map that we had. We've looked at the linear one. Now we're going to look at the quadratic one and try to see how do we then analyze that and how do we solve it. But firstly, we need to define it and see what form it comes in. Right? Let's have a look at it. So, a quadratic inequality, or rather inequalities, are inequalities of the form ax squared plus bx plus c greater than 0, or the very same expression ax squared plus bx plus c less than 0. Right? Remember, it's either greater or less than. But it can also include the equal sign. Now, I know some people will want to see the actual equal sign on the inequality, but because already the inequality is the main sign, I'm just going to add in a bar there, and this bar will mean or equal to. So the first one reads as ax squared plus bx plus c is greater than or equal to 0. You don't say equal to or greater than. You start with the greater than because that's the main inequality that we have there. The second one reads as ax squared plus bx plus c is less than or equal to 0. So it means this whole expression can either be 0 or less than 0, or this whole expression can be 0 or greater than 0. Now, when we want to solve this, we use a graphical approach. Guys, I promise you, if you master this, you will then get this correct. But the graph of y is equals to ax squared plus bx, so I'm going to draw this graph for you, and then try to show you where this particular inequality thing comes into play when we are talking about a quadratic graph. So remember that this is when a is greater than 0, meaning it has a minimum value for the turning point. So it's like your smiley face. You remember when they spoke about that. Now, if you look at this, when you look at this arm here of the inequality, of this graph, I mean, everything that we have here will make this expression here, ax squared plus bx plus c, to be greater than 0. Why greater than 0? It's because this is more like your y, right? And remember, from a Cartesian plane perspective, any value of y that is above the x-axis is always positive. Anyone that is below the x-axis is always negative. So above the x-axis, it's a positive, below it's a negative. But that's not the only one. So my first solution will be x is less than x1, whatever the x1 is there. And because I have another solution but in an opposite direction, I will then use the word or, because it is either this arm here or that arm there. So you can't say this arm and that arm. That wouldn't really make sense. So on this side, you will then say x is greater than x2. So it's when this expression is also positive. Why? Because it is above the x-axis. But as soon as it becomes below the x-axis, this less than 0 means that it is a negative, right? Remember that. Less than 0 means negative according to the number line. So my solution there will be the one that I use an and now. I don't use an or. So my x values will be greater than x1 and less than x2. So it's like it is in between two values. Now that's where the difference between the and the or comes in, right? The and means that it is trapped between two values. It is between this and that. But the or will mean that it's either this or it's that. So you can see how I'm showing you this based on the graph that I have. I said it's this arm or that arm there, but with the less than, it's between this and that. And then when you then say it using the inequality, you will say it's greater than the minimum value and less than the maximum value. So that's how you then look at the difference between this and part and the or part that we normally use when it comes to inequalities. Now, let's just do an example, right, that has to do with solving this using an inequality. So remember, this graph is a negative graph, right? But we hardly deal with a negative graph. I always say to you, with anything that you do, always make sure that the x squared, its coefficient is always a positive. So I will need to divide this by a negative. And to do that, it means this will be the same as 2x squared plus the 6x minus 5. But if you divide by a negative, remember, the inequality changes the direction. So now it's greater than 0, meaning it's now when it is positive instead of when it was negative. So in terms of a graph, if I want to look at this, it will then be, because we are still focusing on it as a negative. Remember, negative is always below the x-axis, right? For it to be below the x-axis, it will be that arm there, and it will be that arm there. Why is it 2 arms? It's because as soon as you divide by a negative, it then makes it a greater than. So it's like you are reflecting this graph and making it to be a graph that we are used to that looks like that. So it is that arm or that arm there. So my solution for this then will then be this arm that I have here and that arm there. But if I now make it to be a greater than or equal to 0, it means that 0 is part of the solution. And where is this thing 0? It is 0 on the x-axis, right? So at this point and at that point, that's where my solution is. And because we're talking about it being greater than that, it will then be trapped between these two values. But remember I said if it has a bar, meaning it has the equality sign, we then shade our circles. So my solution on this graph will be between there, using a shaded circle from the minimum point to the maximum point that we are using. Now, the method for solving this algebraically, because I just showed you using the graph, firstly, you must make sure that you write it in standard form. So the inequality must be in standard form, where a is greater than 0. And how do you do that? If it's not, you divide by a negative in order to make it greater than 0. And you find the roots of the equation. When the other word for roots, we normally call it the critical values, which I will just say it's CV. So it's like the critical values. That's where we're going to use our starting point. So the 2 roots that you're going to find will be our starting point to talk about the solution. You then use either a table or a number line to check whether the regions of that inequality holds true at all times. Because remember, it's all about making the inequality to be true. A typical example will be x squared minus x minus 6. I said you must write it in standard form. Already you can see it is in standard form. Then you find the roots. The roots are like your x value. So this is minus 3 and x plus 2. So it means my 2 roots, as I've shown you here, will be x is equal to 3 or x is equals to minus 2. Remember, what did I say? I said we also call this critical values, because you will see some textbooks use the word critical values. Now, because we want this solution to be less than 0, to be less than 0 from the negative 2 going to the right, to the left of it, it's more like our graph is like that. So it's above the x-axis. It's above the x-axis. So that does not hold. But between the negative 2 and the 3, we are below our x-axis. So it means our solution will then be, we check this using the table, as I said. If I take anything that is less than the negative 2 as a negative maybe 4, it will then be a negative answer there. Anything between the negative 2 and the 3 will give me a negative as well. And then anything greater than 3 will give me a positive if I substitute it there. And the other part of the root is x plus 2. I take anything less than negative 2 will give me a negative. But now let me actually show you what I mean, because someone might be asking, what exactly does he mean when he says take anything less than negative 2? So let's say my x is negative 3 plus 2. my solution will be a -1. So that's what I mean when I say it gives me a negative. And then if you take 0, which is the one that is between these two values, it will give me a positive. And when I take any number greater than the 3, will then give me a positive. Now the goal will be to multiply the two brackets, and if you do that, you'll land up on a table that looks like this, right? Where it's a minus, minus, plus, minus, plus, plus, and then you multiply them. Negative by negative gives me a positive, negative by positive gives me a negative, and then positive by positive gives me a positive. But where do we want our solution? We want our solution to be a negative, meaning less than 0. So on this last part here, whatever that gives me a negative will then be my solution for this inequality that I have. So you can see automatically from this that it's when x is greater than -2, or rather, and I mean x is less than the 3. So it will be between these two values that I have there. So if I write it down as a solution, will then be that's how I will then write it down. So firstly, always make sure that it is in standard form as an inequality. Find the roots. When I talk about the roots, I'm talking about the x values, right? Solve for x, factorize, and get to the 2x values as though it's an equal sign. What do we call those? The critical values. And then plot them on a number line such that you then have a smiley face like that. Try to use a table in order to analyze where that particular solution will be either positive or negative, depending on what the inequality is that I gave you. I want us to take a quick ad break. When we come back, I'm then going to do specific questions now where I'm actually solving and showing you how to go about first writing it in standard form, finding the roots, and then representing it on a number line and writing your solution. Please stay tuned. I'll be back just now. Hi guys, welcome back from the ad break. So we are on our last segment for the show. Now I'm just going to look at purely questions that have to do with inequalities and try to show you what is it that I've been talking about for all this time, right? Because then talking about all of these things and not showing you what I mean will then really be useless. So for now, let's look at the actual questions together. I'm going to solve them step by step and show you how you represent it on a number line at the end. So let's have a look at these questions. The very first one says solve for x. So at all times, by the way, they will say to you solve for x, right? How you solve for x, I said you must always make sure that this is in standard form, meaning the a value here must always be positive. So this will be x squared minus 5x minus 6, and this will be greater than 0. Remember, this changes direction when you divide by a negative, right? Changes direction when you divide by a negative. So you will then need to find your 2x roots, which are our critical values. So let me just remove that inequality, the equality, and show you how you actually solve it. So this will still be greater than, it's x minus 6, and it's x plus 1. Now, when you get to this step, you then will then say CV, which means critical values, is x is equal to 6 or x is equal to -1. So this is how you then follow it in terms of writing your solution. From here, you go straight to the number line because that's where you will find your solution. So I'm just going to go to a new one, right? Remember, we are still talking about x squared minus 5x minus 6 greater than 0. And then I said it becomes x minus 6, it becomes x plus 1, greater than 0, then my critical values are x is equal to 6 or x is equal to -1. Now this on a number line, I will have my minimum value, which is -1, my maximum value, which is 6. If I wanted to show you this as a graph, it will then look something of this nature, right? Now, what do we want here? We want this graph to be where it is a positive, right? Where it is a positive, remember greater than 0 means positive, means that it is above the x-axis, above the x-axis. So on this particular number line of mine that I drew on my graph, you will look at the solution as whatever that is above the x-axis. So it will be that arm there, and it will be that arm there. I'm just shading it, but when you write your solution, you don't necessarily need to shade it. So it means my x will be less than -1, or my x will be greater than a +6. And that's how you will then write your solution. So you don't just then, as soon as you get your critical values, you then somehow just go and say, x is greater than the 6 or x is greater than the -1, because that's what some people will do. They will treat this as an equal sign, because remember, when you are dealing with an equal sign, you go straight to equating the two. But here, that's really not what you do. You must draw the graph to show where this is true. Look at another example. It says solve for x. Firstly, I said make sure it is in standard form. So this becomes 3x squared minus 2x minus 1 less or equal to 0. And then you factorize this, less or equal to 0. If I factorize it, it will then be 3x and 2 there, and it will be x and 1 there, or 1 and 1 rather, not 2. I'm already looking at the middle term, so it's 1 and 1, and then 1 will be negative and 1 will be positive, right? And my critical values, please guys, look at how I'm writing my solution. This is how you follow the procedure of writing the solutions. The first one will be 3x is equal to -1, meaning x is equal to -1 over 3, or my x will be equals to a +1. So for this one, I'm just gonna take the critical values and plot them. I'm not gonna rewrite it. But the very important thing will be this less or equal to 0. That I must already have. So remember, my critical values are x is equal to -1 over 3, or x is equal to 1. On a number line, the -1 over 3 will be here, and the +1 will be there. If I draw this as a graph, it will look like that, because it's a positive graph, right? So we need a solution for this where the graph is less than 0, meaning where it is below the x-axis, right? So remember that at all times, guys. You can also just make these types of notes whenever you are practicing your maths, so that you can always remember what exactly does it mean, because some people don't really understand what the less or equal to means, or the greater or equal to, or just the less or just the greater. But always just try to make some notes for yourself. Where is this less than 0? We said it is below the x-axis, but also on the x-axis. Why? Because of that bar there, that means equal. So my solution will definitely be there, and it will definitely be there as well, right? And it must be anything that is below the x-axis, meaning it is between those two shaded dots of mine. So my solution will then be at that point, and in between there. So if you write it down mathematically, you will then say x must be less than +1, but my x must be greater than minus 1 over 3. But because of the shading that I did here, it means I must also include the bar for the two things that I have here. Now, another example to look at, this is a difference of two squares. You must just factorize this. It becomes x minus 7, x plus 7, less or equal to 0. My critical values will be x is equal to 7 or x is equal to minus 7. And then you draw your graph again. To draw the graph, I'm just going to draw it here because I have some more space. It will be negative 7 and positive 7. I want it where it is below the x-axis. Where it is below the x-axis and also on the x-axis because of the bar. It means it's from that point to that point. So my solution will then be x is less than 7 and greater than negative 7, but also equal to them as well. One last example before I then look at my summary for the show. This will quickly be factorized to be x minus 3, x plus 1 greater or equal to 0, right? My critical values are x is equal to 3 or x is equal to negative 1. On a graph, this will look like this. I will have minus 1 there and 3. Remember, this is greater than, so it starts there and it goes above the x-axis. It starts there and it goes above the x-axis. So it will be x is less or equal to negative 1 or x is greater or equal to 3. And those will be my solutions. Guys, I really hope you understood that. Now, quickly, our summary, you always need to make sure that you go back and revise the meaning of the inequality signs, to remember again to change the sign when multiplying or dividing by a negative number, find the critical values, which is what I did, sketch the graph, number line or table to find the values that satisfy this. And really, guys, that's all that you need to do. I hope you had so much fun, as much as I did. But for now, I have to love and leave you. Until next time. Remember, though, mathematics is food for the soul.